Hello, today I will explain about the numerical solution of equation. For non-linear equations such as x power of 3 minus e power of x equal to 0, there's no exact formula to solve this equation. Therefore, we will use a common methods with the two main parts. The first part is the finding initial approximate value, and the second part is we improve this value by an iterative process. Okay, how can we find the initial approximate value? There is two methods, and the first method is the graphical methods. The graphical methods is divided by two parts. The first one is the plot and sketch graph y equal to fx, or we can rewrite the fx equal to 0 to the new form fx equal to gx. Okay, example. Let's say the equation is x minus 1 power of 2 equal to 3. So we just minus the both side and we get x minus 1 power of 2 minus of 3 equal to 0. So this part will be fx and 0 will be the y. Why we choose 0 as y? Because at the graph we will use the point of intersection of the line fx and y equal to 0, or we can say the x-axis. So from this graph fx, the graph is the line is intersect at the 2 point of the x-axis. So it means it has two real roots. The first root is lie between the negative 1 and 0, and the second root is lie between 2 and 3. That means the roots, the value of x is between negative 0 and 1 or 2 and 3. The second part, we can rewrite the fx equal to 0 to the new form fx equal to gx. So from the equation before, fx equal to x minus 1 power of 2 minus 3, we just change into the fx equal to gx. We just move this 3 to other side and we get x minus 1 power of 2 equal to 3. So we can say this is fx and 3 is gx. So let we make a graph with y. Fx is equal to y1 and gx equal to y2. So y1 is equal to x minus 1 power of 2 and y2 is equal to 3. So from this graph, the roots is the point of intersection between the two graphs. So the first intersection between the y1 and y2 is between negative 1 and 0. That means there are roots between negative 1 and 0. And the second one, the point of intersection of the graph is between 2 and 3. That means it has roots between 2 and 3. The second method is the sign change method. This method is very easy because we just substitute the x value, but it's hard to get the value of x nearest the approximate value. So from the equation before, we just substitute the x equal to negative 1, and then we get the value of y, and then we substitute the x equal to 0, then we get the value of it is negative 2. So it has a different sign. Different sign means it has a real root between them. So it means it has real root between negative 1 and 0. What if we substitute x with 0 and 1? So if we substitute 0, x equal to 0, then we get the value of negative 2, which means it's a negative sign. And if we substitute x equal to 1, it also has a value of negative sign. It means if they have the same sign, it don't have a root between them. So it don't have root between 0 and 1. Then what if we substitute the value of 2 and 3? So if we substitute the value of 2 and 3, if we substitute x equal to 2, then we get the negative 2. It has a negative sign, and 3 equal to 1. So it has a positive sign. So it has a different sign, that means it has a real root between 2 and 3. So the conclusion is the s minus 1 power of 2 equal to 3. The s value is between negative 1 and 0, or the s value is between 2 and 3.
Now, moving on to Newton-Raphson method. Firstly, you guys have to know what is Newton-Raphson method. Newton-Raphson method is a method to find a better approximation of the root of an equation. Right? If x0 is an approximation to the root of a certain equation, then the better approximation is given by x1 equal to x0 minus fx0 over f prime x0. And then x2 would be the better approximation of x1, x3 would be the better approximation of x2. And you continue until you get a consistent value, okay, using this formula right here. This is also known as an iterative process. Now, we move on to example. So given example from the guy before, fx is equal to x, as you can read here, it is given root between 2 and 3. So if the question does not state a specific x0, you must take an x0 is in the middle of the range, of the root. Right here, I take 2.5 for example here. So, and here, secondly, the equation, we must expand this to make it easier for us to find the first derivative right here, as it was needed in the Newton-Raphson formula. Now, we just substitute fx into this and f prime x into this, and x0 you put it in here, here, and here, and also here. And x1 you will get 2.75. Now let's see if x2 is the same or not. You substitute this x1 to here, x1 to here, here, and here, and here. So you'll get the value of x2 would be 2.73214, which is different from x1. So we continue, we find x3 until we get a consistent value. We substitute x2 into here, x2 into here, and x2 into here, and into here also. So we'll get the value is 2.73205, which is near to this, but still not the same. And we have to find the fourth to get the consistent value. So we substitute this to this like before, just substitute into the x, and we'll get the value the same. Be aware, here you must take 5 decimal places to avoid inaccuracy, and the final answer you must take only 3 decimal places. So here I will do the statement. Thus, x is equal to 2.73214 that is the final answer. Let's say if you take less decimal places, you'll get x2 and x3 and you already finished. And that will be inaccurate. So you must take at least 5 decimal answers. So here I will show you how to use a calculator for the Newton-Raphson method. So here you just insert the equation. Okay. And you press calculate to insert the x, and you insert the x value. Then you press equal 2 times, and then you press, and then you continue by pressing calculator, calculate, and again 2 times equal to, and calculate again. Here you put, just press the answers, no need to copy all that, and just repeat the same process until you get the consistent value. So you get the same value as before. So that's it.